Trans-Alaska Pipeline, as of mid-September 1975, is 29% complete. And by the end of the year, the 800-mile-long oil pipeline is expected to be half finished. For Alyeska Pipeline Service Company, the firm that was formed by 8 major oil companies to build the $6.3 billion pipeline, this is a significant step toward the transportation of crude oil from Alaska's North Slope to the southern ice-free port of Valdez. In the first year of actual construction, following the building of a 360-mile-long haul road from the Yukon River to Prudhoe Bay, 29 pipeline and pump station camps were completed, as well as headquarters facilities in Anchorage. The first pipe was laid March 27, 1975. The summer that followed was the first full construction season for pipeline work, and much of it was a learning experience. The mere coordination of a 20,000-person workforce strung out over 800 miles, then the pipe is lifted by a side boom tractor. 7 different welding passes are made for each joint. A separate welding crew is used for each set, making it possible to link more than a mile of pipe a day. The pipe is then covered with gravel and dirt and compacted. To support all of this effort along the pipeline, millions of tons of cargo have been shipped by barge, rail, air, and overland. To enable crossing of the Yukon River, 2 air cushion transporters, known as hover barges, ferry up to 8 trucks at a time. A bridge across here is now being built jointly by the state of Alaska and Alyeska, and is expected to be ready for traffic by the end of the year.
I've built pipelines in the lower 48, South America, Middle East, Canada. For cross-country pipeline, this is definitely the most complex one that has ever been built. It certainly has been given a much greater degree of design consideration than any pipeline I've ever been associated with. The people who build pipelines are hard-working individuals who know their trade, enjoy their trade, enjoy the outdoor work and the hard work that goes with it, and keep after it. One of the major deviations from normal pipeline construction practice is the construction of the right-of-way, or work pad, as it's called in this pipeline. The work pad is about 55 feet wide and constitutes the limits within which we must work. The work pad is a working strip of selected granular materials overlaying the natural tundra, quite similar to a road. In fact, the way the pad is built, it would be similar to a secondary dirt road in the lower 48. The purpose of the work pad is to permit an access route for equipment and people from one part of the pipeline to another. No piece of equipment ever gets off 2 to 6 feet in thickness, and all the material has to be hauled in. Before the work pad can move forward, the right-of-way has to be cleared by the brush crew. The timber is hand-cleared and cut to fall within the limits of the right-of-way. One of the unique construction problems we had to deal with in this Trans-Alaska project was the existence of permafrost, or permanently frozen ground. We couldn't bury the pipe in the conventional way throughout the whole line. Part of the line had to be built above the ground to preserve the permafrost. Depending upon the location, the permafrost can go down hundreds of feet. So in these areas of permafrost, it's essential that we go above the ground. The vertical support members, or VSMs, were designed for this project to carry the line in the above-the-ground mode, far enough above the surface that any temperature that might be generated by the flowing crude in the pipeline will minimize any sawing of the ground itself. Are made up of 18-inch pipe pieces, of which there are over 13,000 in our section. Each one is drilled and sand slurried, or grouted in, or driven, depending on the subsurface conditions. To allow proper expansion and contraction of the line, and to accommodate potential seismic movement, the above-ground segments are installed in a zigzag or trapezoidal pattern. To control the movement of the pipe, a line is anchored between trapezoidal segments. This pattern then permits the line to actually move on these supports to accommodate changes in temperature. The thermal units are placed in selected piles to aid in preserving the permafrost around the pile.
We use twin internal lineup clamps, and we run them under air pressure. We try to maintain around 240 to 250 pounds air pressure. That's to line the joints up true. Bring the high-low out. If the joint's a little big, it'll get a little bit of egg white, and it'll line it up just nearly perfect. Then the 4 bead ends run what we call a stringer bead. That's the first pass. Of course, here we're using wire. I think it's the best weld there is. And I know for sure Price does. They spent worlds of money perfecting it like they have. Other than that, of course, we have the best welders here in the world. And this is 4/6-2 wall pipe we're on now. The thicker the wall, the more passes you have to make. Other than the stringer bead, they'll have to make 5 passes before it's completed. Of course, that includes a hot pass and a filler. And they'll have to make 3 more passes before the cap.
Unlike the above-ground VSM structure, our ditching techniques for burying the pipeline are pretty standard. We've tried ice saws and special ditching machines in below-ground frozen sections without much success. But drilling and shooting of the permafrost and excavation with backhoes has worked pretty well for us.
Right now we're working a stretch between Eielson Road and Moose Creek 1. We have varied types of soil conditions here. We have an old stream channel with lots of roots and stumps, and also a lot of water here. The water table is about 6 to 7 feet down from the surface. We're moving north. We're making good progress.
Before the pipe is lowered into the ditch, it is coated with a tape material to protect it from corrosion. While the side booms cradle the pipe beside the ditch, there's a sequence of cleaning and heating the pipe before the tape is applied. An open flame heater first dries the pipe. This is followed by a cleaning machine consisting of a series of rotating wire brushes which clean any foreign matter from the surface of the pipe. This is followed by a series of radiant heaters, which preheat the pipe to a temperature required for the application of the tape.
Well, they come up that way, and I'm getting, where we're moving around there. And our grader will be coming from the ditch this afternoon, then we should be able to take care of it.
As long as you got your right clothes to wear, there's no problem at all, but you can't hardly maneuver around. Of course, sometimes it may take one man, sometimes it takes 2 men.
20 RPM, you gotta go for band before it melts.
It's not too bad if you're doing something all the time. If you're standing still or something, it's really cold. But until it gets about 40, 50 below, it's not bad. as long as you're moving really fast. Because if you stand still, you freeze your butt off.
Construction of the Trans-Alaska Pipeline is almost complete. By the end of 1976, all 800 miles of mainline pipe were installed, and work was nearing the final stages at the several pump stations along the route and at the Valdez Tanker Terminal. Alyeska Pipeline Service Company officials say the progress made during 1976 assures that oil will flow from Prudhoe Bay to Valdez on schedule in mid-1977. As late as September, there still was uncertainty that all the pipe could be in place by year's end. With the Alaskan winter about to begin, some of the most challenging obstacles on the project remained to be surmounted. Getting through Adigan Pass in the Brooks Mountain Range, and through Thompson Pass and Keystone Canyon in the Chugach Mountain Range. The first victory in the race with winter involved Adigan Pass, where the pipeline reaches its highest point at 4,800 feet. For more than a mile through this remote mountain pass, special designs were necessary because of unstable soils and avalanche dangers. The ditch was lined with concrete for extra strength, and the pipe was encased in an insulated box to make sure the surrounding soil remains stably frozen when hot oil begins flowing through the line. Another set of challenges faced workers in the Chugach Mountains, where deep snow commonly persists right up to summer. Here, the 1976 push got underway early last spring, and the route through snow-packed Keystone Canyon and Thompson Pass was bombed with coal dust. Blackened snow absorbed more heat and melted faster, providing an earlier start for construction crews. The Keystone Canyon stretch was especially difficult because the pipeline had to be buried in steep, rocky slopes, high up on the canyon wall, instead of on the canyon floor where the going would have been easier. This tougher route was chosen to avoid disruption of traffic on the Richardson Highway. 60% grades and sheer rock outcrops were encountered in the area. Nearly 2 full construction seasons went into preparing the 4 miles of ditch through the canyon. Snow was threatening to extend the job into yet a 3rd season, and workers finished the installation in late September. Just north of Keystone was the last and perhaps the greatest challenge to the pipeliners: the south face of Thompson Pass. Here, special construction techniques were needed to ferry equipment, pipe, and backfill material up the long slopes, as steep as 45 degrees. The above-ground line is designed in a zigzag alignment so the pipeline has flexibility and will accommodate thermal expansion and contraction of the steel pipe. Work remaining in 1977 includes completing insulation of the above-ground line. Installed by a specially designed device called a manipulator, the insulation will keep the warm oil from getting too cold and sluggish should the system be shut down for a lengthy period during winter. Heat pipes were installed in many vertical support members for the elevated line. These thermal devices, which automatically draw heat out of the ground in winter and transfer it to the atmosphere, will keep the permafrost around the supports stably frozen through the summer season. 12 major pipeline bridges were completed during 1976, including 2 cable suspension bridges. The longest suspension span is this one, extending 1,200 feet across the Tanana River, about 75 miles south of Fairbanks. Assisting in some of the weld repairs was an unusual machine the pipeliners call Snoopy. Propelled by a 40-horsepower diesel engine with an exhaust elimination system, the 10-foot-long vehicle carries a welder and his helper through the pipe. Snoopy comes complete with a 2-way radio and its own power system for welding and lighting, eliminating the need for cables.
Pipelining generally takes place in some remote place. Seldom do you ever find the job close to a nice metropolitan area. It seems it's always someplace a long way from home. So in order to pursue their trade, pipeliners have to be transient. They have to go where the work is, and the work is generally someplace other than where they'd like to be. The work is hard, the hours are long, and the life is lonely. But they do it because it's their livelihood, and they're good at it. And I suppose most of them really wouldn't be happy doing anything else.
When the oil starts flowing from Prudhoe Bay to Valdez this year, it will have been almost a decade since the oil was discovered under Alaska's North Slope. During these years, thousands of people and machines have been involved in what has turned out to be the largest privately financed construction project in history.